A common request pattern in data centers today is something called barrier synchronization, whereby a client or an application might have many parallel threads, and no forward progress can be made until all of the responses for those threads are satisfied. For example, a client might send a synchronized read with 4 parallel requests, but suppose that the 4th is dropped. At this point, we have a request sent at time 0, then we see a response less than a millisecond later, and at this point, threads 1 to 3 complete, but TCP may time out on the 4th. In this case, the link is idle for a very long time while that 4th connection is timed out. The addition of more servers in the network induces an overflow of the switch buffer, causing severe packet loss and inducing throughput collapse. One solution to this problem is to use fine-grained TCP retransmission timers on the order of microseconds rather than on the order of milliseconds. Reducing the retransmission timeout for TCP thus improves system throughput. Another way to reduce the network load is to have the client acknowledge every other packet rather than every packet, thus reducing the overall network load. The basic idea here and the premise is that the timers need to operate on a granularity that's close to the round-trip time of the network. In the case of a data center, that's hundreds of microseconds or less.